Should I write 2 inches or 2.0 inches or 2.00 inches? These are the sort of decisions one has to make occasionally when working with data, and these are solved through the use of what's known as significant figures rules, and that's the subject of this screencast. We'll learn all about it, how to apply it, how to deal with it. This is screencast 2.10. Okay, suppose we have the number 32. We're going to teach you some examples, and then hopefully by the time this is all over, it'll all make sense to you. We say that 32 has 2 significant figures. The reason why is you can't write this any briefer than that. Or another way of saying it is non-zero numbers, like this has no zeros, are always significant. Some zeros there. What about the ones in front? Well, this number is said to have only 3 significant figures because leading zeros, these 2 right here in the front, are never significant. Always drop them. Reason? That number is 3.23 times 10 to the minus 2. Supposedly that means only those 3 numbers are significant, at least the way it's being taught here. Here's some middle zeros. Are they significant? Always. This is said to have 4 significant figures. We gotta say 3.004 times 10 to the, well, times 10 to the 0 in this case, but it has 4 significant figures. Sandwich zeros are always significant. And here's 2 close cases, 300 or 300 with a decimal place. This one, it is assumed that they may be counting by hundreds, and so we say it only has 1 significant figure. This one, those zeros really matter. They were counting by ones. That has 3 significant figures. Or, the most picky rule. Trailing zeros are only significant if there is a decimal place, which there is in only this case. Here's one that has a decimal place, central zeros, and a 0 at the end. Well, we do have a decimal place, so they must have been accurate to the hundredth. For example, they were weighing something, and it didn't weigh 300.21 grams. It weighed 300.20 grams, so they want you to know they measured it with that level of precision, so they put that 0 in there. This has 5 significant figures. Summary. Here's one with all sorts of things. A decimal place and zeros leading, central, and end. Leading, always dump them. Middle, never dump them. Final ones, trailing ones that is, keep them if there's a decimal place. This number has 5 significant figures. 1, 2, 3, 4, 5. We just dumped that one there. Okay, a little bit about rounding. What if you have 3.25? If it's 5 or 0, go up. If you want to express 2.25 to 2 significant figures, we say 2.3. We round up. Adding and subtracting. There's a special rule for this. This will eventually drive you crazy, but here it is. The significant figures is based on decimal places when you're adding or subtracting numbers. So 4.16 plus 3.3 is not 7.46. It is accurate only to the 10th, so we would say 7.5. Notice how we round it up. Adding and subtracting, it's a little bit different. It's not based on decimal places, but you keep the fewest number of significant figures. So 999 divided by 333 is not 3. It is good to 3 significant figures, therefore 3.00. Tedious, yes? This is Screencast 2.10.